Hey everybody, welcome to Right Triangles 1, Lesson 3, all about the parallel and perpendicular slopes. It is the rise over the run. It is y1 minus y2 over x1 minus x2, but then we're going to add something different. The Greek letter delta is a triangle, and delta in the world of mathematics means change. So if you write delta y over delta x, that's another way to express slope. Let's see what's true about parallel slopes. Two lines that are parallel would have the same slope. Their slopes would be equal. So in the first blank, write equal. Mark these as parallel, and then let's give an example. If the slope of the top line is 2/3, the slope of the bottom line must also be 2/3. So now let's look at the idea, which is perpendicular. Perpendicular slopes do not have the same slope. In fact, in order for two lines to be perpendicular, one of them has to have a positive slope and the other has to have a negative slope. So we know that in a coordinate plane, two distinct lines are perpendicular if their slopes have or are opposite signs. If one is positive, the other is negative. They also have to be reciprocals of each other. So if the slope of this one is 2/3, the slope of this perpendicular line would be -3/2. So now let's a couple of examples of this slide in your documents. What I would like you to do is in each blank write down in this column the parallel slope. In other words, give me two lines like L parallel to M. What would be the measure of the slope of M if L is this? And then give me the perpendicular, oops, let's use the perpendicular symbol there, not parallel again. Then what slope would make your lines perpendicular? So let's sketch the perpendicular symbol in there. Maybe we won't sketch the perpendicular in there. There we go, there's our perpendicular, whatever the name of that other one is. So take a minute, try those, and then look at the second video to find out if you are solving these correctly.